Hello students, today we are going to start here last one point of this chapter, that is law of conservation of momentum. Law of conservation of momentum. Student, in that concept, listen here. Consider two objects, that is A and B. Two objects A and B. Okay? A and B. Of masses, having masses here m1 and m2. m1 and m2. And initial velocity u1 and u2. Initial velocity. When two object is moving, initial velocity u1 and here u2. It's okay. Two objects here A and B, and masses is m1, m2. Initial velocity of that object moving is u1 and u2. It's clear? When two objects is moving in the same direction, see here, these two objects moving in the same direction. This B, A is moving this direction, B is moving this directions. Is okay. After time t, time is equal to t. A collides A, object A is collide on object B. The velocity of A now becomes v1, final velocity, okay? Final velocity becomes v1, and here final velocity becomes v2. Student, listen again here. A collides on B. The velocity of A now becomes v1 and velocity B now becomes v2. In this case, object A exert an active force on the B. Same time, B also exert equal and opposite reactive force on A. It's okay. In that times, object A exert an active force on B. At the same time, B also exert equal and opposite reactive force on A. Therefore, we can write here force exert by A is equal to force exert by B, because A is exert on the force object B and B is same times exert force on A. So right here F is considered here. Suppose F2 A is, that is F2, we have to consider force B is F1, but F is exert on a object A, therefore is giving here negative, okay, opposite side. So now we know that here F equals to MA, right? So we have to write here F2 is here M2A2 is equals to minus M1A1. Force is mass into acceleration. F2 is M2A2 and here F is M1A1. It's clear? But we know that here A is an acceleration, change in velocity. We know that here A is equals to V2 minus V1 upon T. So now put here value M2 is equal to A2 means here, right here, V2 minus U2 upon T is equal to here minus M1 V1 minus U1 by T. It's clear, student? Okay, in this mathematical expression, give attention careful now. Okay, so now therefore M2, right here in this form, V2 minus U2 upon T is equal to minus M1 v1 minus u1 by t. It's clear. Now tt get cancelled here. Okay. So thereafter we have to write here m2 v2 minus u1 is equals to minus m1 v1 minus u1. It's clear. This t is transferred in their side, then t get cancelled, remaining terms written here. It's okay. Now multiply them, bracket open there, the m2 into v2 minus m2 u1, sorry u2 is equals to minus m1 v1 plus minus plus m1 u1. It's okay. Now student collect here initial term and final terms. So that means here m2 v2 plus m1 v1 is equal to m1 u1 plus m2 u2. It's okay. This term take here another side, and this initial velocity take one side and final velocity take here another side. That means here m2 v2 m1 v1 means here final momentum. Final momentum. Final momentum is equals to here initial momentum. So we have to prove that if there is no net force acting on the two interacting bodies, then their total momentum is conserved. Total momentum is here conserved. If two freely moving bodies collides, we have to conclude that if two freely moving bodies collides, their total momentum after collision is equal to the total momentum before collision. The total momentum, their collision is equal to the total momentum before collision. It's okay, student. We have to conclude that. Okay, we have to prove that law of conservation of momentum. It's okay. So we have to taking here example. Suppose we have to consider that. Consider an example of gun with a bullet. The gun and bullet has mass m1 and m2. Both have zero momentum because both are rest. Total momentum before m1 u1 plus m2 u2 is equal to 0. When the bullet is fired from the gun, the bullet goes in forward direction with a velocity v1, while at the same time the gun recoils at the backward direction. It will have less velocity because gun has larger mass, has two momentum of equal magnitude, but opposite direction exists here also. The total momentum becomes 0. Therefore, total momentum after the collision, we have to return here m1 v1 plus m2 v2 is equals to 0. It's clear, student? Now we are going to take here solve example. See on page number 16. First one example is here. The mass of common is 500 kg and recoils with a speed of 0.25 meter per second. What is the momentum of the cannon? See here, given is mass of the cannon 500 kg, recoil speed is 0.25 meter per second, and momentum is not given. The momentum is find here momentum m into v, that is 500 into 0.225, 125 kg meter per second. It's okay. In that question, find here momentum. So we know that here formula is momentum is equal to m product of mass and velocity. Mass is given 500 kg and speed is velocity is given 0.25. After multiplication, 500 into 0.25, we will get here 125 kg meter per second. It's okay, student. Thereafter, example second is given. The balls have mass. The balls have masses of 50 grams and 100 grams, and they are moving along the same line in the same direction with the velocity of 3 meter per second and 1.5 meter per second respectively. They collide with each other, and after the collision, the first ball moves with the velocity of 2.5 meter per second. Calculate the velocity of the other ball after collision. The student, we are using here law of conservation of momentum. Okay. First of all, see here what is given. So the mass of final first ball M1 50 grams. We have to convert into 0.5 kg. Mass of the second ball is M2 100 grams, that is 0.1 kg. Initial velocity of the first ball is u1 3 meter per second. Initial velocity of the second ball equals to 1.5 meter per second. Final velocity of first ball v1 2.5 meter per second. Final velocity of second ball v2 find not given. The final velocity find of the second ball here. Okay. The first I put here where laws m1 u1 plus m2 u2 according to conservation of law of conservation of momentum. m1 v1 plus m2 v2. Put here value 0.05 into 3 plus 0.1 into 1.5 is equal to here 0.05 into 2.5 plus 0.1 into V2. It's okay. Now after multiplication we will get here this one answer 0.15, and here multiplication we will get here 0.15 is equal to here 0 after multiplication 0.125 into 0.1 V2. Now do here addition 0.15 plus 0.15. So we will get here 0.30, that is 0.3, and remaining term as it is, that is 0.125 plus 0.1 V2. Now this 0.125 take another side, it will goes here negative. 0.3 minus 0.125. So we will get here 0.175. Now 0.1 V2 is a multiplication. So this term take here division of the another side. Okay. Therefore V2 is equal to 0.175 by 0.1. Thereafter do dividing here. Okay. After division we will get here 1.75 meter per second. It's clear, student? Now our chapter is finished. Okay, student, if you have any doubts, you ask me. Okay. And exercise of that chapter, student, now return here, any doubts you ask me. Okay, now stop here.